We're going to begin doing our goal, Unit 7, Goal 6. And this goal is that it says I can use law of sines and cosines to find missing sides or to solve a triangle. And a few things about that. We are only going to go over law of sines first, and then we'll do law of cosines separate. And also notice in there that we're not saying just right triangles now. So you'll see that this is dealing with triangles that are not right triangles. It does work on right triangles, but so we can do this on any triangle, right, obtuse or acute, right, acute or obtuse, but we do have those tools that work well with right already in our at our disposal. So we tend to use that on right law, cosine, the SOHCAHTOA trigonometric functions, and then use acute or obtuse, or use this on other triangles. So this can be used to find missing sides or angles, and this is how it works. And A is the side opposite of opposite of angle A. So then again we have B over, or side opposite of angle B, and C is the side opposite of angle C. So it's the side opposite over the sine of the angle that's opposite of that side will equal this, the next side, over the sine of that angle that's opposite of it, and so forth. And sometimes you see these interchanged. Sometimes they have the sine A on top, and then they just all be interchanged. So it doesn't make a new law. It's just that we know with these proportions, if we put the sine A over A, then this sine B would be over B, and so forth. So there's 3 times that we find this one really useful. And the main things when we're looking for sides is when we have 2 angles. And then there's when we're looking for an angle, if we have 2 sides, we can find an angle, at least 2 sides. But this one we have to be careful because sometimes we can get an ambiguous case. And we'll kind of talk about that later as we proceed in math, but just be mindful of that. So here we're given a triangle ABC with angle A equals 70, B equal 80, and side A equals 12 centimeters. Find the measure of angle C, side B, and C. So in this section where the angles are all capital letters and the side opposite of them are the small letters. So we could draw that out kind of like this here. So this is the information we're given, and we're going to find side B first. So we know law of sines says the side 12 over its opposite side, the sine of its opposite angle, equals, we're looking for B, so B that we're looking for over the sine of its opposite angle, so sine 80. Now we know with proportions that we can cross multiply. So you get 12 sine 80 equals B sine 70. Divide by sine 70. And then we can plug that into our calculator because we know that sines of an angle are just a decimal, so we have 12 times that ratio equals divided by this ratio will give us that sine B because these cancel out. When you're plugging in the calculator, just make sure that you close your angle sine 80 if you plug that all in at one time. So it'll come up automatically with parentheses. Make sure there's parentheses around this 80. Otherwise, it divides 80 by sine 70, and it'll give you an error because you'll have something larger than 1 that you're taking the sine of. So B equals 12.6. Let's say we're going to, just for example purposes, so we can see, looking for angle C, before we find side C, let's say we're given this, and we want to find angle B. I know we had back here what that angle is, so we know it's supposed to be 80. Let's see how we could do that if we're just given this situation. So now we're going to look for angle B, just to look at how that is done. It's the same setup. Just remember, whenever we're looking for angles, we use those those inverse trig functions: sine, cosine, tangent. And since this is the law of sines, we're going to be using that. So every time you see angle, think that you're going to use that inverse function. So we got to find that ratio of what B is. And the way we're going to do that is we're going to, again, set up our law of sines. So 12 over its sine of its opposite angle, sine 70 equals 12.6 over sine B, the sine of its opposite angle. But we don't know what B is, we're saying, for at this time. So we cross multiply. So I get 12 sine B equals 12.6 sine 70. And then divide by 12. So what we have is sine B. When we put this in to the calculator, you're going to get a decimal. So 12.6 sine 70, making sure we put the parentheses around there, 70 divided by 12, gives us the decimal, the ratio, 0.9867. And obviously a little bit longer, but so that's the ratio. We want to know what angle has this ratio. So to figure that out, we do sine negative 1 of that ratio, 0.9867. So second sine in your calculator, 0.9867 equals 80.6, and that reason why that is 0.6 is because this ratio continues and we didn't put that all in there, but we see that it gives us that real close to that angle, that 80 that we saw earlier. All right, so that's how we're going to find side and angle. Let's look at one more, finding the side, and then I'm going to let you work on your homework. So say we have this. Let's look for B. So sine, or 30, over the sine of its opposite angle, which is 35, so sine 35, equals B over sine 30. Cross multiply. 30 sine 30 equals B sine 35, and then divide by sine 35. $26.2. Right. That is law of sines, and we'll go over law of cosines next.